on this question. It says a jar is filled with 56 different colored marbles, 9 of which are red, 20 of which are blue, 27 of which are green. So we get this jar with these 3 different colored marbles. A player is asked to draw a single marble from the jar, and if they draw a red marble, they will win 20 bucks. If they draw a blue marble, they will lose $10, and if they draw a green marble, they will lose $5. You may round your answer to the nearest cent. What is the expected outcome of this game? So like if this was a game offered at a casino, for example, or some, one of your shady friends, or do you have any shady friends? Offered some kind of strange game like this to you. Should you play it? Is it a game where you can win money or lose, or where you lose money? What do you think is going to happen? Of course, it's random. So let's draw out. Well, let's go with the question. It says expected outcome of the game. Expected being the key word. So if we go to the notes, here I am on the exam 2 notes. We're looking at where it says gambling or insurance. That's clearly what we're doing here. Gambling or insurance. If there is a cost, if there is no cost. Well, did they ever mention like it costs, I'll just say no. No cost mentioned. Now you might say, well, it says right here that you could lose $5. Yeah, that's true, but that's not a cost. That's just what will happen if you get a green marble, you lose $5. They don't say it's like $10 to play the game, or $7 to play the game, or something like that. They never mention a cost to play the game. So no cost. So we're here. Is it cost? No, we're doing no cost. So what do? If the problem says expected value for you, if it says expected value for the company, well, it's for you on this one, right? It says you may round. Oh no. What is the expected value of this game? Meaning for you. I mean, player is asked. So it's all about you. No cost mentioned. Expected value for you. Okay, so here we are. No cost. Expected value for you. What do? You add up each dollar winning will be positive, or losing, which is negative, multiplied by the probability of each. So each dollar amount you can win or lose multiplied by the probability of each, and you add those up. Okay. So we got to go over here then. We got to say, okay, what are the dollars? What are the dollars you can, here, right here. What are the dollars you can win or lose in this game? Well, the first thing you could do, let me see, is this you'll win 20 bucks if you do what? If you draw a red marble. So if you get red, you're going to get positive $20. If you get blue, you're going to lose 10 bucks. So blue, that'll be negative, right? It said it in the notes right here, right? Winning is positive, losing is negative. So, okay. And then if you get a green, you lose $5. So green, lose $5. Okay. Now, what do we have to do with that? We have to take each winning or losing amount multiplied by the probability of each. So we have to go right over here and say, okay, so what's the probability of each of these things happening? So, for example, what's the probability, first off, that we're going to get a red marble? When we reach in that jar, we're going to get a red marble. Well, in that jar, let me draw the jar over here. Here's the jar. We have, there's 56 marbles. Total marbles. And it looks like 9 are red. So we get 9 red marbles, 20 blue, and 27 green. If you add those 3 up, that'll be 56. Okay, so therefore, what's the probability of getting a red marble? Well, 9 out of 56, isn't it? Probability of getting a red marble is 9 out of 56. Then we're going to multiply that. What's the probability of getting a blue marble? Well, 20 out of 56, right? Because out of the 56 marbles, 20 of them are blue. Multiply that. It's probably getting a green marble, 27 out of 56. We're going to multiply that. So we're going to take each dollar amount, positive for winning, negative for losing, multiplied by the probability of that thing happening, right? If you get a red marble, you win 20 bucks plus 20 times the chance of that happening, the probability that that's going to happen. Chance you're going to get a red marble out of that jar is 9 out of 56 because 9 out of the 56 marbles in the jar are red. And blue, you lose 10 bucks, negative 10 times the chance of blue happening, 20 out of 56. Green, negative 5, you lose 5 bucks times the chance of that happening, 27 out of 56. So we're going to do that in our calculator. So and then we're going to add these up. That's what it says. I'm getting back to the notes here. It said add up, right? Each dollar amount, winning positive, losing negative, multiplied by the probability. So that's what we're doing. So literally on the calculator here, let me be really exact with what I'm going to type into the calculator. In my calculator, I'm going to take 20, it's positive 20, times 9 divided by 56, right? That's 9 over 56, it means divide, minus 10, right? This negative 10, times 20 divided by 56, minus 5 times 27 divided by 56. I'm going to hit enter at the end of that. Let me see what I get here when I do that. I'm getting, answer I got from all that is negative 2.767. How many decimals they want? Nearest cent. So nearest penny would be, says money, negative 2.77. So negative 277. So that'd be negative 277. Like that. Now, what does that mean? That means, remember what expected value means. It's an average. It means on average, if you play this game lots and lots of times, you reach in there, get a marble, win money, lose money, whatever, you just play it again and again and again and again. The average amount is you're going to be negative. You're going to lose $2.77 per play on average, right? You're not going to lose $2.77 on any one turn. You're either going to make 20, lose 10, or lose 5. But if you play it lots and lots of times, the average, that's what expected. An expected value is an average value. What's going to happen on average, what you expect to happen on average, is it's going to be like you're losing $2.77 every time you play the game, which is how every casino game is. It's always negative on average, meaning they know people will lose money on average. Even though you win sometimes, you lose other times, even though there's a bigger amount you can win, and, nevertheless, the average, more likely you're going to get the other results, and 277. You're going to lose $2.77 every turn on average. Would it be profitable over time to play the game? Clearly not. No. Now, if this was positive 277, then yeah, we'd say yes, it is profitable. But if it's negative, then no, we're expecting to lose money on average over time, like that. Now, if you're wondering, you might be saying, what, Mr. You said add here. Well, it's add a negative, which is really subtraction, right? Because this is a negative number, negative. So adding a negative is the same as subtracting. That's why I just did subtraction and subtraction. If the first number had been negative, like negative 20, I would have needed to go negative on the 20. And on the calculator, I hope you remember, you've got to do the parenthesis negative. So if that first number had been negative 20, I would do it that way. Remember, there's a difference in the TI calculator between a subtract and a negative. This is just right here, a subtract. Why? Because it's between two numbers. Subtraction is between these two numbers. But a negative is only on one number. I didn't need it on this one, but I'm just saying you might on your version. A negative is what's on one number, and that's the one in parentheses at the very bottom of the TI calculator, down below the 3 by the enter button. That's when you have a negative on one number. You've got to use the negative with parentheses. If you have a subtraction between two numbers, that's just a normal subtraction over on the right side of the calculator by the add, subtract, multiply, and divide. And so there we go.